everyone, and welcome to Mysteries of Science. My name's Stevie, and I'm the Deputy Editor of Science and Nature, the monthly magazine from the team behind The Week Junior.
And I'm Michael, the Features Editor. In this show, we explore the strange phenomena and bizarre events that have left scientists scratching their heads.
To celebrate the release of the new Marvel movie Ant-Man and the Wasp: Quantumania, we're taking a journey into the quantum realm, a tiny universe within our own where the normal rules of physics don't apply.
But we're not alone. We'll be guided on our trip by some expert guests who help us understand the weird and wonderful world of quantum physics.
Okay, everyone, take a deep breath. Are you ready to shrink down to the quantum realm?
Oh, I think so, Stevie.
Here we go. This is Mysteries of Science! Okay, Michael, here we are in the quantum realm. How do you feel?
A little bit smaller.
It's pretty weird for sure, isn't it? What is this place?
Well, to understand the quantum realm, which Ant-Man explores in his films, I think first we need to understand what exactly we're talking about when we talk about quantum mechanics.
Luckily, I know just the person to help us out.
Hi, I'm Sabina. I'm a physicist and a YouTuber and an author. I've written a couple of books and I currently live in Germany.
Some of you may know Sabina from her YouTube channel, Science Without the Gobbledygook.
Yes, and did you know that actually we have a YouTube channel as well, Stevie?
Yes, that's right. You can also listen to this episode on YouTube by heading to youtube.com/@Mysteries of Science. In the episode description, you can find a link to Sabina's YouTube channel.
So tell us, Sabina, what exactly is quantum mechanics?
Quantum mechanics is a way to explain how matter works, basically everything around us, like all the stuff, like, the table that I sit at and the computer and also the molecules in the air and everything really is made of small particles, atoms, that are held together by something. And to understand exactly how this works and what properties those atoms have and the molecules that they make up, that's what you need quantum mechanics for. Like, for example, if you want to know, like, what's the color of a certain material, that's basically what you need quantum mechanics for, or why metal is shiny, or why some materials conduct electricity very well and others don't. Quantum mechanics explains that.
Okay, so quantum mechanics is a way to explain how the universe works by looking at things at the smallest level we can, the atomic and subatomic particles that make up everything.
Exactly. And as it turns out, the smaller you go, the stranger things get. Among other things, quantum mechanics says that particles can actually be in two places at once.
Okay, that does sound a little bit strange.
Oh, you've heard nothing yet. Just wait until later in this episode as we go deeper into the quantum realm. Things are going to get a lot weirder.
But why? I mean, why is quantum mechanics so weird?
Well, it's definitely weird in that it doesn't agree with our everyday experience. But then there's the question, like, should we find it weird that it doesn't agree with it? Because it's something that we never really experience. We can't experience it, like we can't see single atoms. So why would we expect them to behave like normal stuff that we're used to? So that's what I try to say in my video. It'd be surprising if we didn't find it weird.
Okay, that's an interesting way of looking at it. Maybe it isn't so weird after all.
Now, Michael, I know you're a big superhero fan, so for our listeners who may not be familiar with the Ant-Man films and what that's got to do with quantum mechanics, could you please fill us in?
With pleasure, Stevie. So, in the first Ant-Man film, a thief called Scott Lang, played by the actor Paul Rudd, joins forces with a legendary scientist called Hank Pym, who, using something called Pym particles, is able to shrink himself down to the size of an ant. Now, he basically wants Scott's help to stop this technology from falling into the wrong hands, and ultimately, this turns Scott into the superhero Ant-Man, who then becomes one of the Avengers and helps save the universe many times over.
Okay, that sounds good. But why would you want to shrink down to the size of an ant? I mean, it doesn't seem like the most super heroic of animals.
Well, they may look small, Stevie, but ants actually have super strength. They can carry up to 50 times their own body weight.
Okay, fair enough. That's pretty impressive. So where does the quantum realm come in, and what is it exactly?
Well, if we're talking about the science behind the Ant-Man films, then why don't we speak to the filmmaker's very own science consultant?
Hi, my name is Spiros Michalakis, and I am a mathematical physicist at the Institute for Quantum Information and Matter at Caltech.
Welcome to the show, Spiros. Now, Spiros was the science consultant for Ant-Man and Ant-Man and the Wasp, the first two Ant-Man movies, so he is the perfect person to guide us through the quantum realm.
Thanks for coming, Spiros. So tell us, how does somebody become a science consultant?
There's a really great program by the National Academy of Sciences in the US called the Science and Entertainment Exchange. And they connected me with the producers of Ant-Man. In fact, I got a call from the director of the exchange at the time, and he told me that there was an opening for a science consulting opportunity in Atlanta, Georgia, if I'd like to take it, and maybe I would even get to meet Paul Rudd there. I didn't expect much, but it turned out Mr. Rudd was there, along with Peyton Reed, the director of Ant-Man and the sequels, and a lot of other amazing people. And I had a great time talking to them about the quantum realm.
Okay, so the quantum realm. We've heard a lot about it. What is it exactly?
In the movies, the quantum realm is actually something that was originally inspired by Stan Lee and Jack Kirby, if I'm not mistaken, the original creators of Marvel Comics. And the idea there was that it was just a microverse, a smaller version, a microscopic version of our universe, with all these different heroes just being like tiny versions of the ones that exist at our scale. And honestly, I didn't know much about this when I discussed the quantum realm as I think about it and as quantum physicists think about it, which has to do again with the ability to be in many different places at the same time, or defy the arrow of time that says that you go from the past to the present to the future. All these different things that become possible when you're looking at the quantum realm in actual like quantum physics. But the portrayal of it in the movies I thought was fascinating, both visually and with the dramatic elements of being in the quantum realm. Because it's very difficult for us as well as experts in quantum physics to visualize and express the complexity, I guess, and the beauty of the quantum realm. So it was really nice to see them try to do that through visual effects.
So the quantum realm isn't just the stuff of science fiction then? It's a real idea in quantum physics?
Of course, yes. It is the realm within which everything happens. In fact, it encompasses not just like the microscopic world. I believe it's the macroscopic world, the whole universe. In fact, the whole multiverse is what you can actually think of as the quantum realm. And what we get to experience are just different facets of it. When we zoom in, it's just a different facet, a different view of the quantum realm. And we're looking at protons and electrons and photons, right? These subatomic particles. When we zoom out, we see galaxies and clusters of galaxies. And when we zoom out all the way and have like this almost infinite perspective, you can see potentially all the layers of the multiverse that combine together in this superposition, which we call, to create the reality that we consider as just being singular.
So in a way, we're all already living in the quantum realm. It makes up everything there is.
Okay, so if the quantum realm then is based on a real theory in quantum physics, then what other ideas in quantum physics were you able to get into the Ant-Man movies, Spiros?
In the original movie, I was surprised to see that the ending was something that I suggested, that they have a connection. Scott Lang, the main character in the movie Ant-Man, has a connection with his daughter. So if you haven't seen the movie, a bit of a spoiler, he gets kind of lost temporarily in the quantum realm. And I suggested that maybe the love between them, that quantum entanglement, connecting them, could bring him back to that particular point in space and time where his daughter was waiting for him.
Quantum entanglement. So what's that?
Quantum entanglement is this amazing resource that we just discovered. It was discovered as part of the foundations of quantum physics that says that things don't really need to be near each other to affect each other. And that kind of went against what Einstein thought, that you have to be very close, reality is local, and if something is going to happen, you better be nearby to see it or to make it happen. But quantum entanglement allows for particles, for example, to be very, very far away from each other. on the other side of the galaxy, and you can do something to the particle that you have here on Earth, and then it would affect the other particle with some strange correlation. It would almost seem like there is a portal that goes beneath space and time, and that's where all these connections exist, all this entanglement exists, from which the space and the time that we observe and we experience day to day emerges from this more fundamental space.
Wait, what? So you're telling me two particles can be completely separate on different sides of the galaxy even, and yet what happens to one can then also happen to the other?
That's right. I told you things were going to get weird.
Yeah, the amazing thing is that they're actually the same thing. They are not two particles, they are one superparticle, higher dimensional entity you may think of. And it's only from our point of view as humans that we see them as being separate entities, separated also in space and sometimes in time. They're actually one object, and we just misunderstand what its real structure is.
Okay, this has blown my mind.
It's just like Sabina said earlier. You can't expect the things we can't see to behave like the things we can see. What we perceive and what is actually possible are two separate things.
So, on the whole, Spiros, how scientifically accurate would you say the Ant-Man movies are?
I don't know if I would call them scientifically accurate, but I would call at least the first two Ant-Man movies scientifically interesting and curious.
Okay, I'm just going to come out and ask the question that everyone who's seen an Ant-Man movie wants to know the answer to. Will we ever be able to shrink ourselves down to the size of an ant?
That is highly unlikely to ever happen. But we are trying to actually do something way cooler, in my opinion, as scientists. We are trying to bring the quantum realm to our size instead of having to shrink to the size of the quantum realm. And that's some of the research we're doing also at Caltech, at the Institute for Quantum Information and Matter, and other places around the world. Some fantastic research by fantastic people trying to blow up to our size, the macroscopic scale, all these amazing quantum phenomena.
Now, this sounds interesting, but how are we going to go about bringing the quantum realm to us?
You may have probably heard already of these new computers we're trying to build, these quantum computers. And one of the first steps to creating macroscopic quantum phenomena and be able to rely on them for some time is very similar to how we're going about creating quantum computers, which requires bringing together a lot of different quantum elements and keeping them alive for a long time at their quantum state. That requires something known as quantum error correction. And really, really cool algorithms then that you can run on them, just like you can run programs and apps on your phone or your computer, but now quantum in nature.
Okay, I've heard a lot in the news about quantum computers. I thought that was just like a fancy new brand of computer. I didn't realize it was quantum mechanics. So what are these quantum computers exactly?
Well, Michael, so normal computers, like the ones you might do your homework on, can only do one calculation at a time. But what Spiros is talking about is harnessing the weird capabilities of subatomic particles that we've been talking about to create computers that can do multiple calculations at once.
Okay, and so why would that be useful?
You can do some really cool stuff with them. And that's why it's so exciting as research right now. You can solve some really difficult problems in much, much faster time than you could ever with even the biggest supercomputer we currently have.
Who knows, Michael? Quantum computers with their super fast calculations could help us figure out some of humanity's biggest problems. Scientists like Sabina and Spiros are working on this all the time, and there have been some major breakthroughs. Recently, in the Week Junior Science and Nature magazine, we reported on IBM making the world's largest quantum computer. Quantum computers could be 158 million times faster than even the most sophisticated of supercomputers. That means it could process in 1 minute what would take a supercomputer 300 years to accomplish. That's some real superpower right there.
Wow, okay, that does sound pretty impressive. Now, I think it's time we crack out our old friend, the mysteryometer. Spiros, on a scale of 0 to 100, 0 being we know nothing and 100 we know everything, how much do we know about the quantum realm?
Oof, this is going to be very subjective, but I would say we are probably closer to 60% of understanding like quantum physics. And the reason why I say that is because quantum physics, in my opinion, is not a theory of physics. It's more than that. It is a theory of knowledge. It's a very powerful, very general theory of knowing things outside of ourselves. And that becomes kind of philosophical. So at that level, understanding fully quantum physics is almost understanding knowledge itself, how to know anything, right, in a complex universe. So there are different layers and different levels of emergence, the same way that biology emerges from chemistry and chemistry emerges from physics. You can imagine also quantum physics emerging from the abstract realms of mathematics. And we're trying to synthesize all of these together and try to understand the connection between them.
60%, that's not bad. And what if our listeners want to get involved to try and crack that final 40%? What can they do?
I would love your listeners to join on World Quantum Day, which takes place every year now on April 14th. There's going to be activities around the world, and you can go to worldquantumday.org to find out more and maybe enter the quantum realm with us. Go watch the movie and have questions.
World Quantum Day sounds great. I'll be there. So, what have we learned today? I think it's time for a quick recap. 1. That quantum mechanics deals with the behavior of small subatomic particles that make up our universe.
2. That the quantum realm is a real place and we're all living in it.
3. Quantum entanglement means that two particles can still be connected even if they're on opposite sides of the galaxy.
And 4. And that quantum computing could help us do some very big calculations.
Oh, and one more, that in a few years we'll all have our own Ant-Man suits.
That would be great. But no, Michael, unfortunately we learnt the opposite to that.
Well, you never know, Stevie. This is the quantum realm after all. Anything can happen.
Very true. Now, we would like to hear from you. Have you seen Ant-Man and the Wasp: Quantumania? If so, what did you think of it? Would you like to shrink down to the size of an ant? What would you do if you had the superpower of Ant-Man? To send us a voice note, head to funkidslive.com/mysteries and hit the big red button. Your message could be played in a future episode.
Now, we're going to be taking a little mid-season break, but don't worry, we'll be back on the 24th of March with our next mystery.
Yes, all the way from the quantum realm, we'll be heading back in time to medieval Britain to try and meet King Arthur.
We all know the legend, but did King Arthur actually exist? Come with us and some expert guests as we go digging for the truth. Until then,
Stay curious.